Hello, this is Unit 1.7. This is metric conversions. Okay, so we're going to be talking about a little bit of a new topic here. This is kind of going to connect with everything we've done before, but it is a little bit different. You don't necessarily need a calculator, but you will want to have your data booklet, and you will want to have your data booklet open to the second page on metric units and conversions. Okay, so we're going to be talking about metric conversions today. So a little analogy here. What do a dollar, 100 pennies, 20 nickels, 10 dimes, and 4 quarters all have in common? Well, they all express the same amount of money. But you notice they express the same amount of money with different numbers. For example, $1 is, well, $1. 100 pennies is also equal to $1. 20 nickels is also equal to $1. 10 dimes is also equal to $1. 4 quarters is also equal to $1. How can things with different numbers be the same? Well, because if you notice, each of them has different units associated with them. And of course, different units have different numbers associated with them. A penny is worth 1, a nickel is worth 5, a dime is worth 10, a quarter is worth 25. So we can express the same information but use different units. And conversions allow us to do this. Conversions allow us to express the same amount of something, can be anything, in different forms or units. They're technically still the same quantity, we just express them with a different number because there's a different unit associated with it. Okay, so for example, I could say I am 6'1" tall. I could also say I'm 190 centimeters or something like that. They mean the same thing, the same height, but they have different numbers associated with them because they are different units. So conversions allow us to express the same information with different units and therefore with different numbers as well. Now, some units are more convenient to work with than others. For example, if I go to the grocery store and I buy some milk, I can buy a 4 liter of milk, for example. I don't buy a 4,000 milliliter of milk. Those are the same volume, but one is more convenient to work with. Typically, the fewer numbers, the better. Another example. When I read a highway sign and I'm driving up the Sea to Sky Highway up to Whistler, and it says 119 kilometers to Whistler, it doesn't say 119,000 millimeters to Whistler. Why? Because again, we want to express it. Oh, sorry, actually that's not even, that'd be 119 million millimeters to Whistler, not 1,000. So in this case, which is more convenient? Well, again, typically a smaller number is easier to work with. The point I'm trying to make here is that even though units can express the same information, some units are more preferable over others depending on the context. Okay, and you're going to learn when that is. So today we're going to focus solely on metric conversions. Now, you may have heard of the metric system before. You have grown up with it. The metric system is also known as the SI system. This is based off of the French who adopted it first, known as the Système International. And this system is used by every country on Earth except for 3. Those 3 are Liberia, Burma, and the USA. Okay? Every other country uses the metric system. And the metric system focuses, as the rest of our numerical system, on the base power of 10. However, what is different is to indicate different amounts of metric unit, we use prefixes. Prefixes allow us to designate which size of the unit you're talking about. A kilometer, for example, 1,000 meters, or a millimeter, 1,000th of a meter. So it allows us to, just with one word, tell you how many, what size the units are, basically. And so every single prefix is associated with a different exponent on that particular base. Remember, your base is always 10, but the exponents can vary. And again, each of these exponents is associated with a different prefix. Now, before we start looking at metric conversions, first of all, you need to know what are metric units in the first place. So metric units you're going to see quite a bit in chemistry are grams, represented by the symbol small g. Liters, representing volume with capital L. Seconds, or time, small s. Temperature in degrees Celsius. You'll see it'll be a small little circle with a capital C. And finally, distance in meters, meters represented with small m. Okay, so you should be relatively familiar with some of these system SI units, their metric units here. There are others. There's newtons and force, there's joules and energy, but these are primarily the main ones we'll be looking at in chemistry. So you should be familiar with these particular units. Okay, one last little thing. Regardless whether you have one of your units or a million of your units, you should never pluralize your units when you are expressing it. For example, if the quantity you're associating with your unit is more than one, less than one, okay, it's anything but one, we do not add, you would, for example, if I describe students, I add an S to it, right, indicating there's more than one. If I have 30 students or 48 horses or $26, I typically add an S to indicate there's a plurality there, there's more than one. We do not do that with SI units. When it comes to SI units, the number is shown with the units, and therefore we do not pluralize it. So for example, if I have 4.58 grams, I have more than 4 grams, or sorry, I have more than 1 gram, and therefore I don't say I have 4.58 G apostrophe S indicating this plural amount. That is shown in the number itself. So we never pluralize units, okay? So this would be correct, 4.58 G, which is 4.58 grams. We would not write 4.58 G apostrophe S. Why? Because again, this is not an object, this is a unit. The number tells you how many of that unit there are, therefore we don't need to pluralize it at all. Okay, so keep that in mind. Okay, so let's get into how we're going to start converting between our metric units. Now, before we start, there are a few things you want to consider every time you are about to convert between metric units. First thing is to perform any metric conversion, first of all, you need metric units. So again, make sure you're working with one of the metric units. Liters for volume, grams for mass, meters for distance, seconds for time, degrees Celsius for temperature, okay, whatever it is. Your SI units should have prefixes associated with them. If there is a prefix present, it will be in front of it. So for example, in this statement right here, I have 7.22 M capital L. If I go back here, I see, are any of these a base unit? Yes, there are. Capital L is liters. Therefore, my base unit is capital, oops, wow, I am really off the ball today, sorry. My base unit is liters. Okay, so I'm just going to color it blue to indicate it's my base unit. In front of it is a prefix. That prefix, that letter, tells me how many of those liters, what size there are. Okay, and we'll go into a second how we distinguish that. But again, the main point I'm trying to get across here is if there is a prefix in front of your unit, it is not your base unit, it is some sort of multiplier of it. Okay, it's going to either be, so for example, let's pretend there's a meter stick standing in front of you. Okay, so a meter stick, a meter is a base unit. If I'm dealing with a smaller value than that, I'll have a prefix that indicates a smaller value than a meter. For example, a centimeter or a millimeter. Those are much smaller than a meter stick. Therefore, I would have those prefixes in front of meter. If it was bigger than a meter, like a kilometer, which is 1,000 meters, then I would have a prefix in front of that indicating that. So the point I'm trying to get across here is when you look at your units, first of all, identify your actual base unit. Is it grams? Is it liters? Is it seconds? Is it degrees Celsius? Is it meters? What is it? Then look to see if there is a prefix in front of it. If there is, this will change the size of your unit. They'll either make it bigger or smaller. If there is nothing in front of it, then it is just the base unit as it is. Okay, we will get back to that though. Okay, so second thing to consider when you are doing conversions today. Regardless of what value you start with, your converted value should contain the number of significant figures in it as your converted value. Conversions do not decrease or increase the number of sig figs in your value. So for example, if I have so my base unit is going to be meters, and I go from 20.4 kilometers and I convert that into meters and I get 20,400 meters. You'll notice in 20.4 kilometers, there are 1, 2, 3 sig figs. In 20,400 meters, there are 1, 2, 3 sig figs. So conversions do not enhance or decrease the precision of your answer. they stay the same. Okay, so you should have the same precision in your starting value as you do in your converted value. Okay, number 3. This we'll go through in a few minutes with the actual conversions itself, but generally, when you start a conversion, you have to identify where your conversion is on your scale. So now is a good time if you want to bring out your, if you haven't, with your, let's go like this. Maximize that. Nope. This is just not working for me right now. Sorry, I'm just gonna make this, okay, go like that, good. Normally I keep the, to make a long story short, I keep the top of my browser open because when I'm recording, there's a little, basically a little signal. It tells me it's recording. I've had times where I've been recording for an hour and then I look at the top and for some reason it stopped recording and I had no idea and I had to re-record the entire lesson. So I tend to have this kind of showing. It's kind of tough to do with my page like this. So I'm just going to try and shrink it here because it's very necessary for me to show you how the, okay, there we go. Now I can see it. There we go. How the, how to use your conversion table here. Okay. And just zooming, let's just go to 100%. It'll be a bit smaller, but now I can fit everything in there. Great. Okay. So first thing is when you are going to perform a conversion, it's important to identify your starting unit. So where you begin. Now, if your unit, whatever your base unit is, has nothing in front of it, it is just a base unit. For example, grams, liters, meters, seconds, degrees Celsius. Okay, you are starting at the base unit indicated here or on the table indicated here. If you have a prefix, for example, here I have a prefix, your prefix will tell you where you're located. So in this case here, where I have 20.4 km, K stands for kilo. Kilo is over here. Therefore, this is my starting unit. I'm going to start here. Okay, so it's very important to identify where you are starting because then it allows you to do a particular way of math to figure out what your answer should look like. So if you're starting with a unit and then the unit it ends up in that you convert into is smaller, for example, I'm going to go from here kilometers, kilo, which is here, to just meters, which is the base unit here. You notice on your table here, it's organized from the biggest are at the top, smallest at the bottom. Over here, the biggest are over here, the smallest are over here. Therefore, kilo is over here, base unit is over here. A kilo is worth 10 times 10 times 10 meters. So 1 kilometer is equal to 10 times 10 times 10 or 1,000 meters. The base unit is always equal to 1. It's always raised to the base power of 0. Remember, any base raised to the exponent 0 is simply equal to 1. So I'm going to convert from kilometers or kilometers to just meters. I'm going from a bigger unit to a smaller unit. As you can see here, bigger unit to a smaller unit. I'm going down here. Okay. Anytime you go from a bigger unit to a smaller unit, the value of your conversion will increase. Why is that? Well, let's go back to our money example. Remember we were talking about money? We said $1 equals 100 pennies. $1 equals 4 quarters. $1 equals 10 dimes. $1 equals 20 nickels. You notice in every single case, when I convert in the money there from a dollar to a coin, the number increases of that unit. Why is that? Because when you go from a bigger unit to a smaller unit, you need more of the smaller unit to describe the same amount of something. So $1, I only need 1 to describe a dollar. For pennies, though, I need 100 pennies. Why do you need 100 pennies and not just 1 penny? Because a penny is worth 100th of a dollar. Therefore, I need 100 of them. So since it's a smaller unit, I need more of them. Or you can look at this picture here. Look at this student whose height. Let's say this is the student's height here, and it's a meter stick, exactly. If I take a smaller unit and I measure the student, you'll notice I will need more of the smaller unit to measure that student the exact same height. Why? Because smaller units are worth less. Therefore, I need more of them to describe the same amount of something. Okay, so anytime you go from a bigger unit to a smaller unit, your number is going to increase. Because again, you need more of the smaller unit to describe the same measurement. Therefore, anytime you go from a big unit to a smaller unit, you are going to be multiplying by the difference in the exponent. And we will talk about that today. In your visual here, you can think of it like, again, an object falling. As it falls, it gains speed. It goes faster and faster. And so its speed increases. Okay, so think about this. The bigger numbers are here. The smaller numbers are here. Therefore, when you go from a bigger number to a smaller number, okay, what happens to the speed of, so imagine this is like dropping a ball off a building. What happens to it? It increases in value. Okay, why is that? Because as you go to smaller units, you need more of those smaller units to describe the same measurement compared to a bigger value. Okay, again, this would be like me comparing you to a kid who's 5 years old. To describe the same height of you, you'd probably need 2 or 3 of them. Because why? They're worth a smaller height each. Therefore, you need more of them. A weird example, but hopefully you got the point across. Okay, and finally, what happens when you go in the opposite direction? What happens when you start with a smaller unit? If you start with a smaller unit and go into a bigger unit, so for example, let's say I start with in the centi of prefixes, so right here, and then I end up in the kilo or over here, okay? I'm going from smaller to a bigger. When you go from a smaller unit to a bigger unit, then your value will decrease. Why? It's the same logic as before. If I go from 4 quarters to $1, why do I need less dollars to describe 4 quarters? Because again, a quarter is worth less than $1. Therefore, when you have bigger units, you need fewer of them to describe the same measurement. Therefore, your number will decrease. So when you're going up the scale, this is like climbing the building. Okay, you're going to go really slow. Your speed is going to decrease, or throwing the ball back up in the air. When you throw the ball back up in the air, it slows down. Right? It doesn't speed up and go up out into space. It slows down because of gravity, of course. And so this is the same thing that happens to your number. Your number will decrease as it goes up. Okay, and we'll describe how to go through that. But again, the logic being, when you go from a bigger number to a smaller number, your value of your conversion will increase. Because again, you will need more smaller units to describe the same measurement as a big unit. The opposite holds true. When you go from a smaller measurement to a bigger measurement, the number of bigger measurements you need will cause your value to decrease. Why? Because you need fewer of the bigger measurement to describe the same amount of something as all of those smaller measurements. Okay, so hopefully that made some sense, but if not, we'll keep going, and hopefully if you got questions, definitely ask. Okay, so now I'm going to teach you how to convert between units. And again, you want to have this table out in front of you. And something you may have noticed, first of all, back here is you'll notice there is something here with the exponent. As I mentioned to you, as we've been talking about sig figs, is that every single number place is a difference of times 10, right? So going from ones to tens to hundreds to thousands, or ones to a tenth to a hundredth to a thousandth, it's always a difference of 10. So it's always base power 10. And as you go from a bigger number to a smaller number, every difference of a place, again, is times 10. But since you're going from a bigger number to a smaller value, it's 10 times less. So 100 to 10 is divided by 10, right? It's one smaller value. Therefore, this would be 10 to the 2. So starting, always start the base unit, which is 1, 10 to the 0. Every time I go bigger, okay, what's 1 times 10? Well, that's 10 to the 1. Okay, the prefix associated with that is deca, shown as the prefix DA. 10 times bigger than that in the hundreds now, or 10 times 10, is hecto. Hecto is abbreviated as small h. 10 times bigger than that in the thousands now, 10 times 10 times 10, is the kilo, represented by the prefix letter K, small k. You'll notice here in these bigger units, it kind of skips. It goes 10 to the 1, 10 to the 2, 10 to the 3. You'd expect the next one to be 10 to the 4, 10 to the 5, 10 to the 6. We don't write them in there. Why not? It's not that there isn't anything there. It's that they are so uncommon. We rarely run into them that we don't really get people to remember them. I personally don't even know what they are. I don't know what 10 to the 4 or 10 to the 5 is. I don't know what 10 to the 7 or 10 to the 8 is. I don't know what 10 to the 10 or 10 to the 11 is, because they're so uncommon. Rarely do we come across them, and therefore we didn't put them here. Those numbers are technically there, And at the bottom of your next page, I did kind of put in blank spaces where they are there. But overall, though, you're not going to see them. Therefore, they did not put them here. So just a heads up on that. The same logic, if this is increasing by tens, going the opposite direction is decreasing by tens. What's 1 divided by 10? Well, it's 1 over 10, or 0.1. This is the prefix deci, as shown here. If you forgot, an exponent that is negative is 1 over the positive exponent. So 10 to the minus 1 is the same as 1 over 10 to the positive 1. 10 to the minus 2 is the same as 1 over 10 to the positive 2. Okay, so just a little refresher if you forgot your exponent rules. So centi, again, we divide by 10. Now we're in the hundredth. What's 1 over 10 times 10? It's 1 over 100, or 0.01. Centi is small c. Dividing another 10. 10 to the minus 3. What's 1 over 10 times 10 times 10? That's 1 over 1,000, or the thousandth place. That is milli, small m. So again, the idea being is that every single prefix has a number associated with it. That number tells you how many of that base unit you have. Deca has 10 of them. Hecto has 100 of them. A kilo is 1,000 of them. A deci is a tenth of one. A centi is 100th of one. A milli is 1,000th of one. So it's basically telling you how many of that particular base unit you have. That's what it does. Okay, so how are we going to actually do these conversions? Okay, so let me just zoom in a little bit here. Oops, zoom. Okay, so how do we actually do these conversions? Going through these conversions, actually, no, I think I can get rid of this. Yes, I'll just reference my one below. That should be good enough. Okay, so for our conversions here, the first step, and always the first step, is to identify your starting unit and compare it to your unit you want to convert into. When you are going from a bigger unit to a smaller unit, you are going to be increasing your value. And therefore, you're going to be multiplying by the differences between the prefixes. Okay? So, my first example here is I have 24 kilograms of something, and I want to convert it into decagrams of something. You will notice my base unit I've highlighted in blue here is grams. There are prefixes associated with both. So, I've got 24 kilograms. Each kilo is 1,000 grams. So I've got 24 of those. And I want to convert it into decagrams. Each decagram is 10 grams. Okay? I want to figure out what is the equivalent amount. Going from $1 to 100 pennies, going from kilograms to decagrams. What is the equivalent amount? So I'm going from a bigger unit to a smaller unit. Anytime you go from a bigger unit to a smaller unit, you are going to multiply, that's why I put these up here, you're going to multiply by the number of differences between those units. So let me show you what I mean. What you're going to do is you can do this in two ways. You can take both of the exponents of your starting unit and your unit you're converting into and subtract them. The difference between them is the number of places your decimal place will move in your answer. Okay? So, kilo is here. Deca is here. Kilo is 10 to the 3. Deca is 10 to the 1. Therefore, I'm going to take 10 to the 3 and subtract 10 to the 1. If you remember your rules with exponents, you simply subtract the exponents. Since they're the same base, you can simply subtract like we normally do in math. What is 3 minus 1? It is positive 2. Therefore, the difference between a kilo and a deca is 10 to the 2, which makes sense. You can kind of see that here. How do I go from here to here? Well, times 10 times 10. That's 10 to the 2, right? Okay, so that is the difference, going from kilo to deca. Next, multiply the difference between the prefixes by the original exponential value. Therefore, I start with 24 kilograms. To go into decagrams, I'm going to take that 24 and multiply it by the difference between them. What's the difference between them? 10 to the 2. What is 10 to the 2? 10 times 10. This gives us a final answer of, every 10 gives you a 0 of 2,400 decagrams, or in sig figs, 2.4 times 10 to the 3. Now remember, whenever you are multiplying and you're moving the decimal, if there is no decimal, assume it's to the far right of your last digit. It's just invisible and you can't see it. Okay, but just imagine that it's there. Now you can do it this way. There's also a way easier way to do it. And what is that? Literally, I told you that every place is times 10, right? So if I go from here to here and here to here, right, going from kilo to hecto, and then hecto to deca, I'm jumping 2 spaces. If each space is worth 2, I'm therefore going to move my decimal 2 spaces to the right, because again, I am adding zeros. I'm multiplying. My number's getting bigger. Therefore, when I go from kilo to hecto, I'm going to add 1 0 to my answer. So now 24 becomes 240. Going from hecto to deca, I add another 0 because it's multiplied by 10 again, making it 2,400. So literally, when you are going from a bigger unit to a smaller unit, every space that you move, add a 0. So if I go from kilo, which is here, to let's say deci, which is here, that's a total of 1, 2, 3, 4 spaces. Remember, each space is times 10, right? So I'm going to take this. So let's say I have 4 kilograms. How many decigrams is that? Well, going from kilo to deci, how many spaces do I move? Each space is a 0. If I start with 4, when I go from kilo to hecto, that's 40. Hecto to deca, that's 400. Deca to base unit, that's 4,000. Base unit to deci, that's 40,000. So to go from kilo to deci, I would add 1 jump, 2 jump, 3 jumps. For every jump, I move my decimal 1 spot. When I do that, I've put in a 0 or a placeholder for each of those spots, giving me my final answer. So in our case here that we just did with kilo to deca, that is 2 jumps. I'm going to take my 24. Let's pretend there's a decimal there. And for each jump, I'm going to add a 0. Sorry, I'm going to move my decimal 1 spot. Okay, so I jump 1. My decimal that's here is going to move 1 spot. I'm going to jump 1 more time to get to deca. I move my decimal 1 more spot. In each of those spots, we now put a 0. So 0, 0. Oops. Give me a final answer. Of course, there is no decimal written there, so I just imagine it there. I'm going to erase it. Would be 2,400 decagrams. Okay, so that's a much easier way to do it. Literally count how many jumps there are between your units, kilo and milli, for example, and then add a 0, or basically move your decimal 1 to the right for every jump. If I'm going from kilo to milli, I'm going to add 1, 2, 3, 4, 5, 6 zeros to my answer. Okay, so it's a much easier way to figure it out. Let's go through another example. How do you go from 89 hectometers to centimeters? So hecto is here, centi is here. The way I just taught you, the real simple way, is to go, I'm going to move my decimal 1, 2, 3, 4 decimal places, and add a 0 in for each. Effectively, I'm going to add 4 zeros to my answer. Give me a final answer of hecto to centi. Hold on, make sure I got it right, to centimeters, right? 1, 2, 3, 4. That should be 4 zeros. Oops, I made a mistake down here. Good thing I caught it. 1, 2, 3, 4, 5. Okay, there we go. Let's change that. Okay. And so it's a lot easier way to do it. The other way I taught you is a good way you need to know as well, because there are 2 units that are kind of outside of, if you remember me telling you, there were some units that stop. Remember, it goes to the 3s, and then it skips 4 and 5 and skips 7 and 8. To deal with those units, you want to use the first method I taught you. So again, the one method you're going to use the most is literally just count how many spaces there are and add a 0 for each of those. That's the easiest. A little less easy, but just as accurate, is, again, combine the exponents. So again, if I'm going from hectometers to centimeters, so hectometers is here, centimeters is here, I'm going to take this exponent here and subtract this exponent here. What is 10 to the 2 minus 10 to the minus 2? Well, it's the same as 2 minus minus 2. 2 minus minus 2 is the same as 2 plus 2, right? Because a negative, 2 negatives becomes a positive. Therefore, 10, that's why I started my initial value incorrect. It should be 10 to the 2. That's why my answer was wrong. There we go. So 10 to the 2 minus minus 2 is the same as 10 to the positive 4, which is 10 times 10 times 10 times 10. So I'm going to add 4 zeros to my answer. Therefore, I'm going to add 4 placeholders, or 4 zeros, giving me 89 hectometers becomes 890,000 centimeters, or as in scientific notation, 8.9 times 10 to the 5. So my recommendation is for the first 6 between kilo and milli, simply use the counting method. It's the easiest one to do. For every space difference between them, move your decimal place 1 to the right and add a 0. Move your decimal place to the right, add a 0, until you get to the unit you want to be in, and you're done. That easy. However, if the unit is outside of these first ones, micro, nano, mega, or giga, or tera, or pico, you want to probably use the first method because it's a little bit more accurate. Okay, so let's go through an example together, and then I'm going to get you to practice some of these on your own. Bad me has the answers here, so I'm not going to show them to you right away. But I want to convert from gigaliters into, into deciliters. Okay, so giga into deci. Now, giga is way outside this. You can look on your data booklet, but over here I have it. Giga is over here, and deci is right here. Okay, so I have provided you a visual to do it both ways, that you can count it or you can do the exponential way. So let's count it first. Giga is here, deci is here. For every space I move to the right, I can move my decimal 1 place and add a 0. So I'm going to start with how many giga? Oh, I just got to look. It's 2 gigaliters. Okay, going into deciliters. So 2 gigaliters, 1 space, 20, 1 space, 200, okay, and so on. So each space I move, I'm going to add a 0. So we're starting here. Let's count until we get to deci. 1 space, 2 space, 3 spaces, 4 spaces, 5 spaces, 6 spaces, 7 spaces, 8 spaces, 9 spaces, 10 spaces. I have jumped 10 times. Each space I jumped is a space of times 10. Therefore, I'm going to add a 0 to my answer. Therefore, I'm going to get 2 with 10 zeros following it, like so. Okay. So 900 and 1 is 10. Make sure you can also express your answer in scientific notation as well. You should be able to do both. The other way I could have done it is I could have combined their exponents. Giga is worth 10 to the 9. Deci is worth 10 to the minus 1. I'm going to take the difference between them. What is 10 to the 9 minus 10 to the minus 1? Well, what is 9 minus minus 1? That's the same as 9 plus 1, or 10 to the 10. Therefore, I'm going to multiply 2 by 10 to the 10, or 10 times. That is 10 zeros. So it's the exact same thing. So either way you do it, you're going to get the same answer. The point being, though, is that you want to make sure that for each thing that you move, or each 10, that you add a 0 onto your digit. And it's really important that the number of sig figs in your starting value, whatever it is, should be the same in your converted value. So 2 gigaliters, 1 sig fig. 20 trillion, no, that's billion. I think it's almost 20 billion deciliters. Okay, 1 sig fig. 2 times 10 to the 10 deciliters, also 1 sig fig. So you should have the same number of sig figs in your values. Okay, for the next few answers, what you want to do is convert from your starting value to your converted value. And what I want you to, so first of all, if you haven't noticed, all the values I picked are going from a bigger unit to a smaller unit. So in each case, you're going to be adding zeros to the right of your answer, not to the left, to the right. It should be getting bigger, okay? And you can use either method you want. You can count the spaces, or you can do the exponents. I actually suggest you do both, just to make sure you're getting the same answer each time. So no matter what I throw at you, you know exactly what you're doing. Okay, so see if you can convert those between the two. Make sure you do one answer in standard notation, one answer in scientific notation. When you're done the work, come back to the notes and see how you did. Okay, checking your answers. Let's take a look. Starting with your first one, 15 kilometers. Kilo is here, centi is here. Therefore, I'm going to add 1, 2, 3, 4, 5 zeros to it. 1, 2, 3, 4, 5, giving me 1,500,000 centimeters. Or you could do kilo is 10 to the 3, centi is 10 to the minus 2, 3 minus minus 2 is 3 plus 2, or 10 to the 5, giving me 5 zeros there. In scientific notation, this would be 1.5 times 10 to the 6, 2 sig figs, 2 sig figs, 2 sig figs. Letter C, 130 megagrams. Mega is here. Converting into milligrams, milli is here. Count the number of spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, I'm going to add 9 zeros to my answer here. As you can see here, that's a 130 trillion micrograms. No, milligrams. Sorry. Wow, I'm all over the place. Milligrams. In scientific notation, also with 2 sig figs, 2 sig figs, 2 sig figs should be 1.3 times 10 to the 11 milligrams. What's the other way I could do this? Mega is worth 10 to the positive 6. Milli is worth 10 to the minus 3. 10 to the 6 minus 10 to the minus 3 is 6 minus minus 3, or 6 plus 3, which is 9. Therefore, I'm going to add 9 zeros here, giving me the answer you see here. Letter D, I want to convert seconds to milliseconds. You will notice there is no prefix in front of seconds. Therefore, it's the base unit. Milli is here. I'm going to start at the base unit. 1, 2, 3. Therefore, I'm going to add 3 zeros to my answer, giving me 24. Oops, hold on, did I do that right? 1, 2, 3. Oops, I didn't do it right. Here I am catching my mistakes. 0 there. Sorry, my bad. Good thing I'm doing this as I go through it and not just showing you. So that'll be 246. Wait. Hold on. No. The decimal is here. 1, 2, 3. 1, 2, and 3. Sorry. No, I was right. Just making sure. 1, 2, 3, 4. Yeah, I was right. Sorry about that. So remember, you're moving the decimal place. Yes, you are adding zeros, but that's only if the space is empty. In this case, the decimal, in this place, I know the number there. So I'm not going to put a 0 there because there's a 6 there. So a better way I should have worded it is it's not just about adding zeros, it's moving the decimal, and then if it's empty, then add a 0 or a placeholder. Sorry about that. I should have stated that more clearly. And again, let's do our math. Base unit is 10 to the 0. Milli is 10 to the minus 3. What is 0 minus 3? Sorry, what is 0 minus minus 3? Well, it's positive 3. Okay, I'm going to add, in this case, 3 decimal places, 1, 2, 3, and that's what I did. Final answer, 24,600 milliseconds in standard scientific is 2.46 times 10 to the 4. 1, 2, 3, 4, yes. Okay, E, 32 hectograms. In this case, hecto is here. Going into, yes, decagrams. Okay, just making sure I got my place here. So going from here to here, that is one jump. Therefore, it is 10 times bigger, adding a 0, or moving our decimal place one spot and adding a 0. So 320 decagrams in scientific notation, 3.2 times 10 to the 2 decagrams, and again, 2 sig figs in all numbers. Letter F, 7 centimeters, and we're converting that into micrometers. So centi is here, micro is here. Centi, I'm going 1, 2, 3, 4 spaces. Therefore, I can move my decimal 4 spaces. 1, 2, 3. So 1, 2, 3, 4, and filling in a 0 for all blank spaces, giving me 70,000 micrometers. Or in scientific notation, 1, 2, 3, 4, 7 times 10 to the 4 micrometers. If I do it the exponential way, centimeters is, my starting unit is centi, which is 10 to the minus 2. Micro is 10 to the minus 6. Minus 2 minus minus 6 is the same as minus 2 plus 6. Minus 2 plus 6 is 4. Therefore, I'm going to move my decimal 4 spaces, and therefore I get the same answer. Okay, final last one. I'm going from kilograms to decigrams. Kilo is here, deci is here. Therefore, kilo, I'm going to move 1, 2, 3, 4. Sorry, I was about to keep going. So 4. Therefore, I can move my decimal place, which is here, 4 spaces, 1, 2, 3, 4, and add a placeholder into each of those, giving me 30,960,000 decigrams. As scientific notation, 1, 2, 3, 4, 5, 6, 7, 3.096 times 10 to the 7, 4 sig figs, 4 sig figs, 4 sig figs. Doing it the exponential way, kilo is 10 to the positive 3, deci is 10 to the minus 1. What is 3 minus minus 1? That is 3 plus 1, or 4. Adding 4, moving my decimal 4 places, I get the same answer. Okay, so it's the same logic of make sure you can do it both ways. You can count the places, and you can also do it the exponential way as well. Make sure you can do it both ways. Okay, our final and last one, we're going to do the exact opposite. In every single example here, you went from a bigger unit to a smaller unit. Therefore, you are always increasing your value by adding zeros or placeholders. We're now going to do the opposite scenario. You're going to go from a smaller unit to a bigger unit. Therefore, your value is going to decrease. Okay? Instead of multiplying by 10, you are dividing by 10. So you're going to get smaller. And the exact same logic applies. But instead of adding decimals and moving to the right and our number getting bigger, we're going to remove our decimal every place to the left. And therefore, it will be getting smaller. And the same logic applies. If you move your decimal to the left and there's no number there, add a 0. If there's a number there, you leave it. But if there's no number there, you're going to add a 0. Okay, let's go through our first conversion here. Let's go from millimeters, which is here, and decimeters, which is here. Smaller unit, bigger unit. So we're going from a smaller unit to a bigger unit. Therefore, using our counting method, move one, move twice. I'm now going to move my decimal 2 spaces to the left. So if I imagine my decimal is here, I'm going to move it. So when I go to milli, that's divided by 10. We move it 1 to the left. When we go to deci, we move it again, giving me 0.02 decimeters, okay, as shown here. Or you can do it the exponential way. Okay, the same logic applies. Milli is 10 to the minus 3. Deci is 10 to the minus 1. What is minus 3 minus minus 1? Well, minus 3 minus minus 1 is minus 3 plus 1. Minus 3 plus 1 is minus 2. What's 10 to the minus 2? That's the same as 1 over 10 times 10 or 1 over 100. So when you divide something by 100, you're going to move it 2 decimal places to the left. So unlike above, where you're multiplying, when you're dividing, you don't move your decimal to the right, you move it to the left. So I'm going to move my decimal place 2 places to the left. And therefore, when I do that, if it starts here, if I started here, I move it 2 decimal places to the left, I get 0.02 millimeters. Okay, and one last example. We're going to go from 89 meters to kilometers. So meters is a base unit. Therefore, we start here. Kilometers is over here. Smaller unit going to a bigger unit. Therefore, we're going to be dividing, and therefore, we're going to be moving our decimal to the left. How many places do we move to the left? Well, we can count. 1, 2, 3. So I can simply move my decimal place, assuming it's there, 3 places to the left. 1, 2, and 3. Giving us 0.089 kilometers. Or we can do the math. Our base unit is 0. Kilometers is positive 3. What is 0 minus 3? Well, 10 to the minus 3. That is 1 over 1,000, or 3 decimal places to the left. Therefore, we're going to move this 3 decimal places to the left. We started here, 1, 2, 3. That gives us 0.089 kilometers. Okay, so this is the exact same logic as before, but instead, the difference is when you go from a small unit to a bigger unit, you're going to be moving your decimal to the right for every place, for every base power of 10, basically. Versus the other way, when you are going to a smaller value to a bigger value, you're moving your decimal now to the left. Did I just say that twice? I can't even remember right now. When you're going from a bigger unit to a smaller unit, you move your decimal to the right, it's getting bigger and adding placeholder zeros. When you're going from a small unit to a bigger unit, you are decreasing, you're dividing by 10, so therefore you're moving your decimal place to the left, and again, adding zeros if there are no digits there. Okay, try the next practice problems on your own, see how you do, and come back to the video once you're done. Okay, let's check your answers. For letter H, you've got 2 centiliters going into liters. So centi is here. Liters, there's no prefix, therefore it's a base unit. Therefore, I'm going 1, 2 jumps to the left. Therefore, I'm going to move my decimal 2 places to the left. If I started here, 1, 2, I get 0.02 liters. Or in scientific notation, 2 times 10 to the minus 2 liters. 1 sig fig in each. Next one, 15 kilometers in megameters. Kilo is here, mega is here, so we're going from a smaller unit to a bigger unit. Therefore, we're going to be dividing or moving our decimal point to the left. Oh, actually, a great way to visualize it is simply the direction your units are going is the same direction your decimal is going. I should have said that earlier. I forgot about that. So when you go from a smaller unit to a bigger unit, you're going to the left. Therefore, your decimal is also going to the left. When you're going from a bigger unit to a smaller unit, your decimal is going to the right, as your units are also going to the right. So that's an easy way to remember it as well. Okay, so going from kilo to mega, that is 1, 2, 3 decimal places. I'm going to move my decimal to the left. Therefore, 15 becomes 1, 2, 3, 0.015 megameters. Or in scientific notation, 1.5 times 10 to the minus 2 megameters. 2 sig figs in each. Using the exponential method, kilo is to the positive 3, mega is to the positive 6. What's 3 minus 6? It's negative 3. Or 1 over 10 to the 3, which is 1 over 1,000. I'm going to move this decimal point 3 places to the left. In this case, 0.015. Okay, letter J, 459 milliseconds into seconds. Milli is here. Seconds has no prefix. It's a base unit. Therefore, that is 1, 2, 3 jumps to the left. Therefore, I can move my decimal place. 3 jumps to the left. 1, 2, 3. Give me 0.459 seconds as the equivalent. In scientific notation, that is 4.59 times 10 to the minus 1. And finally, over the exponential method, milli is 10 to the minus 3. Base is to the 0. Minus 3 minus 0 is just minus 3. That's 1 over 1,000. Or divide your number by 1,000, you get 0.459. Okay, letter K. In letter K, we've got 24,466 decigrams, and we convert that into hectograms. So deci is here, hecta is here. So going number of jumps, 1, 2, 3. That's 3 jumps to the left. Therefore, we move our decimal. 3 jumps to the left, 1, 2, 3, giving us 24.466 hectograms. Or in scientific notation, 2.4466 times 10 to the 1 hectograms. 5 sig figs here, 5 sig figs here, 5 sig figs here. How about the exponential method? Deci is to the minus 1, hecta is to the positive 2, minus 1 minus 2 is minus 3, or 1 over 1,000. Move our decimal point 3 places to the left, 1, 2, 3, giving us 24.466. Same answer. Okay, L, 4,000 kilograms. Kilo is here, giga is here. Therefore, going from kilo to giga, you're going to jump 1, 2, 3, 4, 5, 6. I move my decimal 6 places to the left. Oops, did I make a mistake? Yes, I did. I think I confused giga and mega. I hope I didn't do it in the answer key. Okay, so that's a mistake. So 4,000 to giga is to the 9 and kilo is to the 3. So it's 6 spaces. 1, 2, 3, 4, 5, and 6. So I move my decimal 6 places to the left. 1, 2, 3, 4. So we're at 0.4 and then 5, 0.04, and then 6, 0.0, 0.0. Let me double check. Make sure I have this. My starting value was right. So I had 3. So starting here, 1, 2, 3, 4, 5, and 6. Yes, I have it right. Okay, let's get rid of those placeholders. So 0.004 gigagrams. So this will change the answer over here. Therefore, the answer over here is going to be 4 times 10 to the minus 1, 2, 3 gigagrams. Let's do our exponential method. Kilo is to the positive 3. Giga is to the positive 9. What's 3 minus 9 is minus 6. Or 1 over a million. When you divide this by a million, you get a 0.004. Okay, letter M, millimeters. We go from millimeters, which is here, to decameters, which is here. Therefore, how many jumps? 1, 2, 3, 4. Therefore, I can move my decimal 4 places to the left. So if I started here, 1, 2, 3, 4 is equal to 0.0007 decameters. Or in scientific notation, 7 times 10 to the minus 4 decameters. Exponential method, milli is to the minus 3. Deca is to the positive 1. What's 3 minus 1? Well, that's minus 4. Sorry, negative 3 minus 1 is minus 4. Therefore, that's 1 over 10,000. If I divide this by 10,000, I get 0.0007. And finally, milliseconds into kiloseconds. Milli is here, kilo is here. Therefore, how many jumps? 1, 2, 3, 4, 5, 6 jumps to the left. Therefore, if I started here, 1, 2, 3, 4, 5, 6. Final answer, 0.000702 kiloseconds. Or in scientific notation, 7.02 times 10 to the minus 4 kiloseconds. How about the exponential method? Milli is to the minus 3. Kilos to the positive 3. What is 3 minus positive 3? Well, that's minus 6. What's 1 over a million? Therefore, if I divide 702 by a million, I get this answer here. And so it works. Okay, I have some extra sheets if you do want to keep practicing these. I find students tend to struggle with metric, but once you get the hang of it, it's pretty simple. But again, just practice it and really make sure you get it, because you will be doing these again throughout any physics, chemistry, any science you do now, high school, university, college. So again, the sooner you get it, the better for later. Okay, good luck, and I will see you soon.